Good day, and thank you for attending yet another installment of HORIBA's webinar series. My name is Lance Cizik. I'm the Western Regional Sales Manager. Myself, along with Mick Dolan-Mayer, the Eastern Regional Sales Manager, and Norio Kobayashi, who is our North American Product Specialist. We are your field sales team for HORIBA Process and Environmental. We are led by Dr. Frank DeThomas, who's the Vice President of HORIBA Process and Environmental. Today's webinar will cover the VA-5000 multi-gas analyzer. Just a quick housekeeping note here is our social media platforms. We are on YouTube. We do have a channel where you can find our previous seminars as well as some other information. Just go to YouTube, search for HORIBA Process and Environmental, subscribe to our channel, and you'll have access to all that. We are also on all the other platforms, Instagram, Twitter, Facebook, and LinkedIn. So we ask that you please reach out, follow us. We ask that you like us. You know, there's a lot of good information that's being posted out there very often. So we thank you for that. So just a quick agenda reel as far as what's going to happen today. I'm going to very briefly talk about who is HORIBA, where did we come from, where are we currently. I'll talk about our Houston facility. I'll talk about our products, and then I'll pass it over to Norio so he can follow up with the VA-5000 presentation in more depth. Who is HORIBA? Well, we were founded back in 1953 in Kyoto, Japan, under the premise of the sale and the manufacture of analysis and measurement technology. Since that time, we've grown to just a shade under 7,200 employees working out of 49 global locations. And in 2019, we did just a bit over 1.8 billion in US dollars in sales. So where does that 1.8 billion come from? Well, there's 5 segments that fall under the HORIBA umbrella. First is the automotive test systems, which is probably our most famous, if you will. I'll say widely known. It's our emission monitoring systems, automotive testing systems. Then we have process and environmental, which is our division, obviously, which is air quality. Environmental water quality is another part. And then we have our medical, our semiconductor, and our scientific division. So these are all 5 divisions that fall under our umbrella, our basis. So just a bit about that Houston facility, Pasadena, if you will, just a bit more specific about that. It was originally founded back in 1985, and it was under Cameron Process. It was purchased by HORIBA in 2012, and we opened this new facility in 2018. It houses 100% HORIBA employees, and those employees would be CAD designers, project managers, electricians, mechanical engineering, and more recently is our manufacturing. We'll be manufacturing all of our analyzers out of this facility. This is something we're very excited about. Service, support, delivery will all be handled out of this facility. More specific about this particular site in Houston, some of our brief capabilities here. We do analyzers, we do analyzer shelters. So our goal is to provide a total turnkey solution for our customers, going all the way from engineering to design to fabrication to startup installation and further product documentation. We offer field service. Obviously, we can have our people come to you. We also have the ability, we have field service depots. So if you have instrument repairs that need to be done, that can be done out of our Irvine office. And we also have embedded service contract options as well. We have certain customers that have asked us to embed HORIBA employees under a contract for them to maintain the HORIBA analyzers that they have on site. It's really kind of a way for them to make sure and to rest easy in knowing that their emissions monitoring systems are going to be up and functioning. And then we also offer RADA testing. If that's something that you're interested in, please feel to reach out to either myself or to Mick, and we'll be happy to help you in any way that we can. Now, a bit more specific about the capabilities and the capacity of our Houston shop. It's just around 30,000 square foot, which gives us the ability to put 22 shelters, each being 10 by 20 by 9 in a climate controlled environment. And then we have an exterior covered area that we could put 8 shelters out there for additional testing. So plenty of space to handle the workload. Some of the capabilities, we have sample conditioning system construction that we can do in there. We can do rack construction, again, shelters, enclosures of any kind. all of the process electrical and mechanical integration. We can do HORIBA analyzer integration, obviously, but I think something that we really want to focus on is we have the capability and the experience to integrate non-HORIBA analyzers. So if you have a GC, if you have a mass spec, if you have a turbidity analyzer, say, that you may want to have installed, that's something that we have the capability and we have experience doing. Again, if you have any questions about these types of things, definitely reach out to myself or Mick. We're happy to help in any way, shape, or form. We have some of the best integrators in the business, the best pipe benders, and we're very good at what we do. So we look forward to hearing from you on those types of scenarios. Lastly, we'll talk a bit about our products. Everything that we do is gas analysis. So whether it's a trace gas analyzer, an ambient air monitor, portable gas analyzer, which 2 weeks ago we did a presentation on the PG300. That's on our YouTube channel. Please search that and subscribe. We also have the NDIR+7000, which is, again, kind of the flagship of all of our products. That presentation was last week. It's also posted on the YouTube channel. And then we have today's presentation, the VA-5000 multi-gas analyzer. So without further ado, I'll pass it along to Norio, and thank you for your time, and we look forward to working with you.
All right, thanks, Lance. Hello, everyone. My name is Norio Kobayashi. I am a product specialist of HORIBA. Today, I am going to make an introduction of the VA-5000. Here are the quick outlines. The VA-5000 is multi-gas analyzer using NDIR+CLA chemiluminescence and a variety of oxygen analysis. It has a 5.7-inch touch color display. It comes with the TCP/IP 4 to 20 mA analog outputs and the digital I/O. Automatic auto correction of measured gases. Auto calibration with the sample system. LCD display has a graphic mode so that you can see that trend as well. USB stick port is to record the measurement data or update the software, setting files, etc. For the SEMS users, the blowback control is also available. So, the VA-5000 can make multiple measurements up to 4 parameters. You can measure NO, SO2, CO, CO2, CH4, ammonia, and moreover N2O, propane, etc. Those parameters are measured by NDIR. Also, another chemiluminescence module can make NO measurement, especially low concentration. All SEMS users need this chemiluminescence for the NO measurement. For O2 measurements, there are 4 selections of O2 measurement principle from PMA, Zirconium, MPA, Galvanic. I am going to explain detail later. Let's look at the VA-5000 applications. There are some of the examples right here. Laboratory use for the experiment user would be institute universities. This one is continuous emission monitoring system. Because the VA-5000 series meets the 40 CFR Part 60 or 75 US EPA requirements. Another application would be a biogas plant for the methane measurement with CO2 or 2. Some of the user uses VA-5000 for engine testing or boiler check, QC process for appliance such as a general oven or gas burner. Air separation plant is another application for the VA-5000 to check the process in the plant. Here is a table for the basic measurement of components: CO, CO2, CH4, NO, SO2, N2O, ammonia, O2, NO. As you can see, those parameters can cover from 100% to ppm level by providing different type of cell. Basically, longer cell can measure lower concentration, and the short cell is for higher concentrations. Also, I wanted to say each cell can have up to 5 ranges. So, for example, CO 0.5 millimeter cell, you can have a 10% to 100%. And you can have 5 ranges between 10 to 100, like 10, 20, 50, 70, 100%. Okay, let's talk about the display and the menus. Main display showing the measurement information. You can see O2 corrected to measurement data and graphing right there. For the setting, you can do a blowback setting, O2 correction setting, and access to the internal analyzer information. This one is main display and it can show 4 parameters, each measured values. On the right side, there are the ranges. To change the range, you can simply tap the ranges on the right. Here are the menu icon and the calibration icon to make a calibration. When you tap trend graph icon right there, then you can see that measurement trend graph. Here is the graph of the measurement. Each line is showing the measurement trend in full scale. You can adjust the timeline, of course, if you don't need to show the specific parameters, and you just uncheck the box on the right. In the menu, there are setting mode. You can schedule blowback timing. This is used to put the air in the probe backward to the sample point so that dust corrected on the filter goes away back to the process. This function always helps the performance of the probe filter and the lifetime longer for the probe and the pump. You can schedule the starting the date, time, and interval and how long you want to blow. As well as the blowback setting, you can do the schedule auto calibration as well. Here is another display about the analyzer internal information. With those information, our technician can see how the analyzer status is going. So basically, if you have something wrong with your analyzer, you can send this data, or another tech can see this display, then we can identify where the problem comes from. Alright, this is just for the information for the spec. The most of functions are in the standard spec, such as O2 correction, atmospheric pressure correction, concentration alarm, flow alarm, remote range switch, auto range switch, blowback, auto calibration, and hold measured value during the calibration. Digital contact input outputs and analog outputs, Modbus TCP/IP communications. You may want to consider the additional sampling systems if you don't have any sampling unit. The lead time is really quick. Our standard lead time is about 2 to 4 weeks for the standard manufacturing. All of the parts are located in the Houston factory too. This is a top view of the VA-5000. As you can see, there are 3 bench modules, position 1 to 3 plus galvanic O2 cell. All of the analyzer modules are packaged each. This makes things easier for the users to replace whole module. Actually, we designed those modules for the replaceable to make plug-and-play replacement for the users. Okay, let me go over the technical information. VA-5000 uses NDIR measurement method. NDIR covers from a ppm level to percentage. We keep the measurement cell at 140 degree F. Keeping the cell warm helps the improvement of the measurement, because ambient temperature change is one of the biggest factor of fluctuation of the measurement value. Also, it helps to keep the sample gas dried and the moisture away. Moisture may capture the sulfur stuff and it damages the cell or causing drift. NDIR cells has an atmospheric pressure correction as standard and always work for the compensation to each component. Here is how NDIR works. The sample gas flow in and out of the sample cell, and the IR light alternately radiates through the sample cell and the sealed reference cell controlled by a chopper, and the gas being measured will absorb IR energy in the sample cell. It reduces the pressure inside of the chamber in this detector. The detector gas flows from the second chamber to first chamber because the first chamber's pressure is reduced. And the flow sensor right here is measuring how much flow occurred. And the amount of the gas flow from a second chamber to first chamber is related to the gas concentration. Alright, another measurement module, chemiluminescence. Chemiluminescence module provides 0 to 20 mA low NOx concentration, and it is not affected by quenching effect of CO2. Actually, quenching is well-known problem of the chemiluminescence, but we use the dilution air to dilute the sample gas, and this helps to cancel the effect from quenching of CO2. Chemiluminescence works when NO reacts with ozone. Part of the NO is oxidized to become nitrogen dioxide, which is NO2. Part of the NO2 generated is in excited state. The luminescence of NO is proportional to the concentration. This is how we measure the NO. As I showed, O2 measurement modules has 4 types: MPA, PMA, Zirconium, and Galvanic. MPA is one of the great ways to measure O2. Generally speaking, O2 has strong magnet properties when it is exposed to the magnet field. O2 molecules are attracted with the magnet field. Utilizing this principle, we designed our own way to measure O2, which is called MPA method. This is a simple schematics to show how it works. Sample gas flow like from in to out. The electromagnet, while it is off, O2 is not attracted to the field. And this area we feed carrier gas. So while electromagnet is off, sample and the carrier gas flow smoothly. When electromagnet is on, O2 starts being attracted to the magnet, and this causes a pressure increasing inside the chamber of the detector. This increased pressure bends the membrane, and the degree of the bending of the micromembrane is related to the O2 concentration. The beauty of this method is because detector doesn't touch the sample, so it won't have any damage or corrosion from the sample gas. Although you need a carrier gas, anyway, you're going to use the zero gas. We use the part of the zero gas for the carrier gas. With that being said, MPA measurement method has a longer lifetime. PMA dumbbell is widely accepted to the many SEMS users in the States. This method also uses strong paramagnetic properties of the oxygen. Sample comes in to the chamber and O2 interact with the magnet field, causing the dumbbell rotation. Photocell senses the rotation of the dumbbell and applies a reverse torque to the dumbbell to return to its original position. The torque applied is linear to the O2 concentration directly. But as you can see, the sample gas going through this, so which means all of the sensor material is going to be touching the sample gas. If you have a corrosive component in the sample gas, so the PMA is going to be affected. Zirconium oxide O2 modules. Zirconium O2 is considered as another electroanalytic detector for the oxygen. A thin layer of platinum coats a ceramic disc. See this blue disc here, and when the zirconium O2 is heated at 800 degrees C, oxygen ion migrate through the ceramic disc. Ion flow through the ceramic disc from higher O2 concentration to lower concentration. Please see the picture here. You have 2 chambers divided by ceramic disc. One chamber is continuously fed by sample gas, and the other one is fed by reference air. Oxygen migrates from higher concentration to lower concentration to take a balance. Zirconium method is detecting this migration it is related to the concentration of O2. Lastly, galvanic O2 modules, there is anode, cathode, both electrodes are immersed in electrochemical solution. O2 enters through a permeable membrane, causing an electrochemical reaction at the anode. An electromotive force resulting from the reaction is measured, and it is related to the oxygen concentration. As a summary of O2 module, MPA is one of the best ways to measure O2. Detector has no contact with the sample directly, not affected by other gases. The PMA is universally accepted, no measure affected. Durability may be lower than MPA because of physical contact with sample gas. This zirconium method has interference of combustion gas such as CO, HC, hydrocarbons. Please make sure the concentration of CO is lower than 2000 ppm in your sample gas. Other than that, zirconium is another good method to measure O2. Galvanic method is the lowest cost driven and work with a battery, so which require you to replace this like every year. It is tolerant to the CO2 and it will deteriorate the detector. But it is still the low cost for running. The most tough thing for the continuous measurement is always downtime, and you cannot wait for service analyzer tech for the repair sometimes. HORIBA VA-5000 was designed for users. User can replace the analyzer module by yourself and reboot without service tech. Silver box is the module you want to replace. It will take 15 minutes to replace, so you can load the file after replacement, then all set. No HORIBA service crew is required. And today I'm happy to announce you that we have another attractive plan. It's warranty program. You can buy extended warranty with the $2,000 per year. It covers all replacement parts including analyzer modules. Each module costs you a couple of $1,000, and this warranty program, $2,000, covers up to 4 modules for another year. Contract can extend up to 5 years. This is a great deal, and you will basically cover the whole things with this contract. Here's another option for the sample system, the VS5000. There are 4 types of sampling system according to the analyzer modules. Sampling system is used to treat sample gas for the optimal measurement performance. Basically, knock off the moisture and filter the dust, and proper pressure and flow is provided by using sampling system. Especially MPaO2 is very sensitive to the pressure, so proper design of the sample system is required. There is a view of the front panel and the rear panel, the pump switch, mixture catcher, selector valve for the calibration line, sample line, and the flow meter, needle valve to adjust the flow sample. Let me talk about the sample system with the flow schematics. This is the flow schematics for the analyzer. The first of all, drain separator will drop the moisture out, and the mixture catcher will catch the SO2, and you don't want to carry SO3 forward because it damages the analyzer. And here is a line selector from a sample line or cal line. Alright, this is the filter, replaceable, and the pump inside. And here is the sampling cooler unit, saturated at 5 degrees C to drop the moisture. And these are the needle valve to adjust the flow. And you can hook up with another VA-5000 by hooking up with the sample outlet too. And the drain comes out from the cooler and to the drain outlet. This is the different flow schematics sample unit with the MPA. Like I said, MPA has two pumps. One is pushing and the other one is pulling. By using different two types of pump, we are maintaining the proper pressure in the flow. Alright, let's go from the sample inlet, going through a drain separator to knock out the moisture, and the mist catcher, and the line selector is right there, and filter and a pump, and the cooler unit is always saturated at the 5 degrees C to drop the moisture. Like I said earlier, you can hook up with the another VA-5000. And this is the MPA bench analyzer modules right there, which needs N2 as a carrier gas and sample gas going out. Here is the second pump, pulls the sample to exhaust, and gas is exhausted from VS5000. Or a part of the carrier gas, nitrogen is also used for the zero calibration. NDIR installed in series. And this is the another sampling gas system with the chemiluminescence analyzer, NDIR analyzer, and the PMA analyzer. Here's a drain separator to knock out the moisture and going through the mist catcher. Here is one line and another line going through a NOx converter, because orange line is showing the raw NO line and the pink line is a NOx line, because NOx converter converts NO2 to NO, so you can measure the total NOx. And the filters, pump, and through the cooler, and going to the analyzer. Okay, in the meantime, you are sucking the air because you need to produce ozone to react with NO. That is how the chemiluminescence works, right? The fresh air is going through an air filter and going through a SO2 scrubber, and the cooler is maintained at the 5 degrees C saturated, and going through an ozone generator, sample will meet the ozone in the analyzer, so a chemical reaction is going to be made. Chemical reaction formula is like this. The sample gas is going through a deozonator, which decomposes the ozone, because ozone is harmless to the human being, and you don't want to smell the ozone. We decompose ozone before exhaust. This is the last page of my slide. I'm showing the spec for the sampling system. Just keep in mind, we provide the customized sample system as well. We design for the variety of the conditions. The sample system into the cabinet or wall mount, make it a class 1, Div 2, however you like. We provide the solution. The VA-5000 is one of the flexible analyzer, and we are looking forward to working for your project soon. Thank you for your time and have a nice day.